Okay, I think we're in good time. Hello, everyone. I'm Arthur. I'm a customer engineer at Soda. And today's webinar will introduce you to one of the new exciting features that Soda has launched. And this is Soda's and the fastest and most accurate data observability. So I'm a customer engineer at Soda. That's my contact email. And just some housekeeping before we get started. Feel free to ask any questions in the Q&A section at any point of this presentation, and we'll get to them either at the end of this webinar or via other communication channels. And of course, this webinar is being recorded and it will be available for you to view again on demand online at the end of this webinar. So let us begin with the agenda for today. So we'll basically talk a bit very briefly about what exactly observability is. And then we'll also have a look at how observability is actually supported and featured in Soda, and how Soda helps you to detect anomalies in minutes at scale and with minimal setup. But of course, we'll also explore and we'll also explain how data observability is just one of many of Soda's features for you to achieve end-to-end data quality in your organization. And we'll basically illustrate how you can, together with data observability, also leverage more of Soda's features, for example, notifications, as well as data testing, to basically establish end-to-end data quality and establish trustworthy data in your organization. So as promised, what exactly is data observability? So here we have a definition where data observability refers to the monitoring and assessing of the health of your data throughout its life cycle, throughout the processes that it goes through as part of your data pipelines, for example. So this is an ongoing and continuous process where basically information such as metadata, metrics, and logs are analyzed and used to basically detect issues, to detect anomalies as they arise, and the detection of these anomalies, and of course, subsequently, the fixing and the prevention of such anomalies from happening again is how basically trust in data is established. So with this idea of data observability in mind, how exactly is data observability achieved with and in Soda? So that's where we talk about metric monitors, which basically serves as the foundation of data observability in Soda as a data quality platform and tool. So what exactly are metric monitors? As the name suggests, metric monitors, they are about metrics. So they're basically time series, time-based records and tracking of metrics, where there's also a maintenance of the historical values of these metrics for analysis and for the establishment of baselines and the identification of patterns, for example. So of course, these metrics and their historical values alone are not sufficient for data observability. There has to be some way to basically detect also any deviations. And that's where Soda's proprietary anomaly detection, machine learning algorithms come into play, where using these metrics and the historical values, and so the baselines and patterns that have been identified, these proprietary machine learning algorithms that Soda provides out of the box basically help to identify any anomalies. So that's basically the definition and the concept of metric monitors for data observability in Soda. So as the title and the name of the webinar suggests, and probably the reason why many of you are now joining this webinar, we did mention the fastest and most accurate data observability, and not for nothing. So now we'll actually jump into the setup of this data observability, into the setup of these metric monitors using our launch demo to give you an idea of exactly how fast, how accurate, how simple, and how scalable these metric monitors are. So these are just screenshots, but here you see later on we'll share at the end of this webinar a link to our launch demo where you can basically try out the setting up of these metric monitors for yourself. But here, let me check. I see Does the data okay, I see a question, but I will attend to that maybe at the end of this webinar. So right now, you should be seeing, let me double check if the correct screen is being shown. Yes, so this is the starting screen when you sign up for our launch demo, when you sign up at beta.soda.io to create an account. So basically, once you have created an account, the next step would be to connect to a data source. And for the purposes of this launch demo, Soda has basically prepared a Databricks data source and data set for you to basically try out the new features that Soda is launching. One of which is these metric monitors for data observability, which is the topic of our webinar today. So as mentioned, of course, the first thing you would have to do, even though it's minimal configuration, there's still some connection needed. So as mentioned here, you can see that Soda has already pre-filled these values in for you, where we gave the name of the data source. In this case, for metrics monitors and for this data observability feature, you would require a connection to your data using a Soda agent. So this Soda agent, it can be deployed on your own Kubernetes infrastructure, and it's basically responsible for executing checks as well as these monitoring of metrics on a regular and automatic basis against your SQL-based data warehouse. So an alternative to deploying this Soda agent on your own Kubernetes infrastructure is to basically use a Soda-hosted Soda agent, which also does the same without the basically the work needed to deploy this agent on your own infrastructure. So in this case, for the purposes of this launch demo and the purposes of this webinar, we'll stick with the Soda-hosted agent. So there's also some assurance of Soda's SOC 2 Type 2 compliance, which guarantees the security of the information that you have on Soda's side. And here, as mentioned, these are the details to connect with Soda's sample data source and data set for the purposes of this launch demo. So with these basic connection configuration setup, you would then proceed on to the next step. And here you can basically see how easily scalable it is when it comes to data observability and metric monitors with this basically no code data set registration and selection interface. So in this case, as mentioned, because it's part of the launch demo, we have provided a sample data set. And so this data set has also been selected by default. But of course, imagine having more data sets and more data sources. It still remains very scalable, where you can easily select at scale in bulk the data sets that you want to establish data observability and to easily set up metric monitors on. So we've done connection, we have done selection, and for the final step is more details about metric monitoring itself. So for the purposes, once again, of the launch demo, we definitely want you to try out and see for yourself one of Soda's shiny new features. So metric monitoring has been enabled by default. And here you see more configuration details when it comes to metric monitoring. For example, the monitoring schedule, which here is by default defined at a fixed time period, where basically the scans will be executed automatically on this regular basis to update and to keep you aware of your metrics monitors. Another important configuration and also a key advantage of Soda's metric monitors is the ability to basically backfill and backtest on your historical data up to 1 year in the past. So in this case, it has been configured to be 90 days in the past, but a huge advantage of this ability to backfill and backtest using up to 1 year's worth of historical data is you get a lot faster time to value as compared to more publicly available algorithms and models where you use machine learning, where basically once you set them up and you connect them to your data sets and your data, for example, you would need to let them run and be accustomed to your data for, let's say, 3 to 4 measurements and days before these metric monitors can actually identify patterns, establish baselines, and basically bring you any value and help you detect any anomalies. But as mentioned, it's a key advantage with Soda's proprietary anomaly detection algorithms and metric monitors. With this capability to backfill and backtest for up to 1 year, This gives you a lot faster time to value, where basically these algorithms, they are immediately trained and also tested on this historical data, so that from the get-go, once this connection has been set up, as we'll see later on, it can already help you start identifying anomalies based on patterns and baselines established using that historical data. So this is faster time to value. You can also even detect, for example, unnoticed anomalies in your historical and past data and realize maybe this is a recurring anomaly based on seasonality, etc. And as mentioned, this helps you identify and establish baselines and patterns immediately once you have connected with your data. Another important configuration when it comes to metric monitors is the time partition column. So this time partition column, as the name suggests, is a data or timestamp column, and it is basically used to naturally group rows in your data set into discrete and regularly updated partitions. So just to give a better idea of what this time partition column could be, for example, if you have a table of, let's say, orders that your customers place, then a natural and a good candidate for your time partition column would, for example, be the order date, so the date where your customers have placed an order, and the date and time where that row, that order as a row, those values have been added into that data set of order data. Another example, if you have a data set of events, then a good time partition column candidate would, for example, be the event time column, which contains a date, a timestamp, a date time, which basically signifies, once again, when the event actually happened and when the event was actually recorded, added, appended into that data set of events and the data attributed to those events. So as mentioned with these examples of a time partition column, there are some key or basically ideal characteristics for candidates of this time partition column. As mentioned, they should of course be a date or timestamp type column. And of course, ideally, these timestamps should basically be arriving in a regular cadence, so in a predictable schedule, for example, where orders or where events are added on a daily, hourly, minutely basis. Another important criteria when choosing a time partition column is that it should reflect basically the accurate ingestion or arrival or addition time of that row into that data set. So for example, it should be when an order is placed and not when that order was first received further upstream in, for example, 5 steps ahead in your pipeline. So it should exactly be when that order, when the event, or when that row was first originally created, originally added into that data set. Because later on, we'll discuss how this time partition column is basically used, for example, to determine the freshness of data. And that's why this timestamp, this time partition column should accurately reflect the ingestion of that row of those events in that data set. And finally, this time partition column should also serve as a logical partition boundary. So basically, it should slice and partition your data as you would expect. So of course, this time partition column, later on we'll see with the metric monitors themselves, these time partition column will be used for partition-based monitors on the data set as well as on the column level, so that, for example, any delays or any backfills of data, they can immediately be detected and show that this data was not updated, this data was not ingested, added as expected. So given those characteristics and as highlighted what the purpose of this time partition column is, Soda will try definitely its best to auto-detect this column, or of course you can also override it and basically suggest which column should be used. So you can see as specified here, the column for this launch demo will be created at, which basically reflects the time when each row is added into this sample data set that we're looking at today. So here, once again, for the purposes of the launch demo, all of the dataset level metric monitors will be configured and set up, and we'll see exactly how this works. So once again, fast, accurate, simple, and scalable. So once you have ran through all these necessary configurations, and when you click on finish, I will have a drink of water, but apparently there's not enough time because that's exactly how fast the metric monitors were actually activated and ready for us to have a look at. So here in this case, as mentioned, it's a sample data set from Soda's data bricks that we have provided here. And in that short seconds or milliseconds, very fast basically, you can see already that these dataset level metric monitors are already, they have already basically been activated. They've even used the historical data as specified 90 days of historical data. And you can see already that some anomalies have been detected as indicated with these red points. So before we jump and explore those dataset level metrics in more detail, let me already set up this column level metric monitor and let it run in the background so that it's ready for us to take a look at later on in this webinar. So here on the dataset level, you can already see out of the box under the metric monitors tab for each dataset, you have both dataset level as well as column level metric monitors. So as mentioned, it was fast. We have seen that it was simple in terms of connection, but you can see also in the setup of this dashboard, in the setup of these dataset level metric monitors, it's also very simple and it's also scalable, where you could basically select multiple data sources and data sets in bulk. So here you can see that on the dataset level, we are basically tracking for high-level metric monitors, for example, the total number of rows, the change in your row count, any schema changes, and also as mentioned, with that time partition column, it will also help you, for example, to check the number of rows in the latest time partition, and also the freshness of your data in that latest time partition. So these high-level dataset level metrics, they're basically ideal for catching any structural or pipeline-related issues across a large number of data sets. So here you can see for each monitor card, basically a name of what that metric is, a description, of course, of what that metric is trying to monitor, and of course, the expected value and some patterns. So if you actually click into one of these metrics, you can see, for example, that it still remains very simple, not just to connect and configure, but also to use, where users can simply adjust these sliders to focus on a time period that they're interested in. Here, you can also see that users can configure exactly how they want to use these metric monitors to identify anomalies. It can detect both anomalies above or below a certain threshold, but you can customize that, for example, to only detect anomalies that exceed an upper threshold or that breach a lower threshold and not on the opposite side. There's also other customization, for example, specifying values that you want to exclude from the detection of anomalies, and also adjusting the sensitivity with which these algorithms will help you detect any anomalies. So with machine learning algorithms, we know that they improve with more user training and more feedback. So here you can see it's also very easy for users to provide such feedback. For example, if an anomaly has been detected, but it could, for example, be a false positive, you can simply indicate that feedback. And this will also be used to improve the detection of anomalies moving forward. So worth mentioning here, although it's not the focus of today's webinar is just about data observability, but Soda is built as an end-to-end data quality platform, and that's why there's also this feature, this functionality, for example, for users to create incidents, which they can then assign to data sources, they can assign to the owners of this data to ensure that someone or team of people are basically aware of this anomaly. They will follow up on it, and they can eventually implement a fix that hopefully also prevents this anomaly from happening over and over again. So as mentioned, besides dataset level metrics, so we saw, for example, that time series. As for schema changes, it is expected that these will not be able to use historical data to detect anomalies, but just to give you an idea of this is how it would look like, where schema changes, for example, the change in the column type, and also the addition or the deletion of columns will be detected by these metric monitors. And for example, it even shows you changes in the index or the position of the columns because of other columns that have been added or deleted, for example. So if we head back to this launch demo, you can see also that besides these high-level, out-of-the-box data set level metrics, users can also basically customize on a more granular level, column level metrics that are also powered by Soda's proprietary machine learning algorithms. So here, earlier on, you saw me add a single new column level metric, but with this interface, these metric monitors can be added in bulk. And worth mentioning also is that the creation of these monitors are automatically typed, so they're dependent on the type of value in these columns. For example, because this is a string type column, so obviously you cannot monitor an average because that's for numerical based columns. And there's also no checking of freshness, which requires a date or timestamp type column. So here for string type columns, as you have seen earlier on when I set it up for payment method, if we do the same, for example, for numerical columns with the average value, here you can also, just as we saw in that interface earlier on, you can basically customize the threshold, include exclusion values, etc. And worth mentioning here is that at this point, even though you only see these 3 metrics that can be monitored on the column level, this is just for launch week, and we will have many more column level metrics that you can set up and monitor in the coming weeks. So once you have selected certain column level metrics to add, you would click on Add to Monitors, and you can see that there will be an automatic prompt to basically run a scan to also include and use the historical data for the new column level metrics that you want to monitor on. So within each of these individual column level metrics, you would also have that similar graph, which is also very user-friendly to basically customize and to detect and follow up on any anomalies that have been detected. So if we head back to this interface, here you can also see that it's basically not just detecting of anomalies, but once you have configured, once you have customized and set up the metric monitors that you're actually interested in, we basically support opt-in alerts and notifications where users can basically click on any of these metric monitors and customize on a very granular level notifications so that they only stay aware and alerted on metrics that they care about. So if we click into an example of this notification, here you can see the name, which type of metrics it should cater to. And here you can see the addition of recipients. So in this case, for the launch demo, it's just an email address, but with integrations that Soda supports, for example, with popular communication tools like Slack and Microsoft Teams, you can basically get customized granular notifications at the relevant communication tools that you, as well as your organization, uses. So before we head into the slides, so we have talked about the setting up of both data set as well as column level metric monitors. We've also seen basically how the user interface remains very friendly, even for example, for business users who do not have to do any programming or coding, and they can immediately leverage and take action using these metric monitors. And of course, these metric monitors do not work in isolation. You can also integrate them with any communication and notification tools where you want to stay alert and aware of any anomalies that have been detected. So we have seen how fast, how accurate, how simple, and how scalable it is. And you'll be wondering probably what's going on behind the scenes. So as mentioned, these metric monitors, they are powered with Soda's proprietary anomaly detection and machine learning algorithms. So just some key facts about these algorithms is that first and foremost, they've been developed entirely in-house. So this basically gives Soda full control over the stack, and this ensures transparency, customization, and also explainability, which are very important as we understand when it comes to AI and machine learning. So this is particularly important and essential for us to ensure that these alerts, these anomalies that have been detected, they are as trustworthy and they're as reliable as possible. And of course, since they're developed in-house, there's no reliance, there's no dependency on any third-party frameworks. And besides being fully developed in-house, these algorithms, they've also been shown and tested to have a 70% improvement in the accuracy of anomalies detected as compared to the Facebook profit model that we were previously using. So this 70% improvement is actually a metric that we have tested and found out using our own proprietary evaluation framework that we basically have hundreds of internally curated data sets as part of this framework to rigorously test the performance of the models that we provide to you for metric monitors. So this evaluation framework also allows us to repeat and also have experimentation very rapidly but still in a very structured way so that we can continuously benchmark and also test the improvement of any new techniques or models that we want to use for metric monitors. And of course, as mentioned, we prioritize accuracy. So this evaluation framework and this improvement in anomaly detection also shows and allows SODA to prioritize the reduction of false signals and false positive to ensure that alerts are always accurate, meaningful, and reliable. And of course, we've also talked about the huge advantage that comes with being able to backfill and backtest on historical data. And yes, finally, this data observability is not working in isolation. You can tie it in with notifications and alerts so that these anomalies that you actually care about can actually result and prompt action to ensure good data quality in your organization. And besides notifications itself, as mentioned, SODA is an end-to-end platform. And another key feature that we see as working in combination with data observability is data testing. And we can here see basically how these two features of SODA, when it comes to the detection of data quality issues, basically should complement and should be deployed in combination. Because observability, we saw how fast, how scalable, and how simple it is to set up. By the end of the day, machine learning and AI, it's great, but it's not 100% perfect. We are as accurate as we can be, but there will still be false positives that this machine learning algorithm will basically alert you on. As compared to data testing, where in the next webinar, you'll basically see how users can collaborate on data contracts. It requires more effort and more investment in the explicit definition of rules and expectations of data. But we know for sure that once these rules have been established, and if they fail, it is a definite indication that a real data quality issue exists. So basically, SODA ties in and provides these two features for a robust data quality strategy, a robust data detection strategy in your organization. So with that, for data observability, if you want to try it out for yourself, how fast, how scalable, how accurate, and how simple it is to set up, simply head on down to this launch demo where you can create an account and play and explore around with metric monitors using the sample data set as we saw earlier on in this webinar, and have a taste of metric monitors yourself. And of course, as mentioned, observability does not work in isolation. It should be used in combination and complement data setting. And for that, we have collaborative data contracts, which is another shiny new feature that SODA is launching as part of this launch week. So you can register for more information at launch.soda.io or in the chat or some communication tool as part of this Zoom webinar. There's also a link to the webinar, a LinkedIn link, where my colleague Hazem, a fellow customer engineer, will take you through this shiny new feature for data testing called collaborative data contracts. And of course, if you don't like trying it out for yourself, if you do not like listening and watching a webinar, there's always our documentation with the link below and also in the chat, where you can deep dive into more information about these, as well as more of SODA's features and functionality. And that's the end of the webinar. Feel free to also join us on our SODA Slack community, where you can always pop more questions, more thoughts, more insights, more feedback at any time. So I think I'm a bit over time. I see what a question. Does data have to go to on-premise? So in terms of the security of data, we have a important security-based question here. So basically, SODA does not have access and can be disabled from collecting any of your sensitive or row-level data. So all this data does not need to be collected and does not have to be extracted from the security of your data storage and architecture for these metric monitors to work, because these metric monitors, they use aggregated metrics and metadata. So that's the only thing that has to basically be extracted from your data system. But sensitive values, sensitive row-level data, which might have like personal information, you can basically disable SODA, whether it's for data testing or for data observability. SODA does not have to take that data out of the security of your data infrastructure. So just to be clear from a security perspective. Okay, so at any point in time, there's the documentation, there's tomorrow's webinar, there's also us always ready and available on Slack. So thank you very much for taking the time and looking forward to joining you on your data quality journey with SODA. Thank you.